Welcome to the online lectures for software engineering. In today's class, we'll be discussing creating an architectural design. Now, first we'll be starting what is a software architecture. The software architecture of a program or a computing system is basically the structure of the system. Whenever you draw an architecture, it means that you're designing how the entire software is going to look like, how the entire structure is. Now, what is this structure going to consist of? It is going to consist of It comprises of software components, then the visible properties, externally visible properties of these components only. And what is the relationship among these different components, how these are connected. That is what a software architecture is. Now the next one is, what is a architecture? We have studied what is a software architecture, we know, but what is the use of an architecture? What does it represent? This architecture, it is a representation that is going to enable you three things. What are the three? Analyze the effectiveness of design in meeting its stated requirements. When you know you have to develop a particular software that need to have so and so requirements, so you're going to make a representation, or you're going to make a diagram, a graphical diagram, or you can make a model of how the components are going to fit in, how they are going to be connected, what are going to be their properties. So this is going to help you analyze the effectiveness of design, the design that you have made, how effective it is. You'll get to know. Then the second one is, consider architectural alternatives at a stage when making design decisions is still relatively easy. When you make a design architecture, then you'll get to know how effective that software is. If you know that the software that you're developing, if it is less effective, then you can make changes within the design. So that is the advantage of making architecture. You can go for different alternatives. If this is not working, the other architecture style should be working, you can make changes. Then the third one is, reduce the risk associated with the construction of the software. Now, if suppose you before creating an architecture, you directly go for construction of the software. So if you have to make any changes within the software, it is going to cost you more. But if you're making the changes within a particular model, then it is going to reduce the cost also, and it is also going to reduce the risk. So these are the 3 points why making an architecture, making an architecture is going to benefit you. Then the software architecture consists of two levels of design parameter. That are the two types of design representations, the data design and the architectural design. Now, what does this each mean? The first one is this data design. Now, this data design is going to enable you to represent the different components of architecture. What are the different components within an architecture? You will get to know that. And what are the different class definitions within an object-oriented system? You'll get to know these two things. What are the different, you're designing the data design. So what are the different components within that data design, and what are the different class definitions that you're using within an object-oriented system? Then the next one is an architectural design. Now this design is going to focus upon the representation of is going to focus on the representation of the structure of the software, the overall structure, how it is going to look like. It is going to focus upon that representation. That is, this is going to focus upon the different components, the properties and their interactions. It is going to focus upon these three things. Then why are we studying this architecture? Why it is important? We'll study this. There are three key reasons that is why the software architecture is important. First, it is going to enable communication between all parties interested in the development of the computer-based system. That is whatever software that you are developing. Many people are involved in the development of the software. Now here, parties means the different stakeholders. The stakeholders are your different parties. So it is going to help communicate between the different stakeholders. So you get to know what are the different requirements for each stakeholder and how you're going to fulfill all of them, or how you're going to compromise a few and add a few. That is going to help you. Then the next one is it highlights early design decisions that will have a profound impact on software engineering works, that flow, and ultimate success of the system as an operational entity. So as you're making an architecture, it is going to tell you whether the design that you're following, whether it is going to be successful or not, whether it is going to embed all the different requirements of the end user or not. You'll get to know that the different requirements, whether they are there or not, or whether they are fully functional or not, you'll get to know when you make an architecture design. And this also helps you benefit in the entire success of the system, because when you're making an architecture, you know different functions, different requirements, how they're connected, what are the different components, what are the relationships between them. This is going to help you within the successful development of this particular software. That is your operational entity. The operational entity is your fully working software. Then the third point is architecture constitutes a relatively small, intellectual, graspable model of how the system is structured and how its components work together. Now, by making an architecture, you'll get to know what are the different components, how they're working, how they're connected. Structure is, you can say it is like an overall view. And this, as you're making a structure out of it, this is very small. It is intellectually graspable. That is, it is easily to understand. People can easily identify. People when you have a diagram, it becomes easy for people to understand. So it becomes intellectually graspable for the system. So that is why designing an architecture before you develop the software is very important. Then the next is data design. Now, what does this data design do? It translates the data object. Now, if you remember what a data object is, a data object, it is a representation of anything. It can be an external entity, a report, a thing, an event, a phone call, a role, place, a structure. So it is going to translate this data object into a data structure at the component level. That is, this is done at the component level. And a database architecture at the application level. This becomes your database architecture at the application level. So at two levels, you've got two different views of your data design. It is going to transform your data object into a data structure at the component level and into a database architecture at the application level. Now, component level is, it is going to tell you a component is going to tell you what are the different components within the software. So you'll get to know the different data structures, how they are implemented. Whereas at application level means it is how you work, how you're working with the software, how it is going to be represented at the end user's view. So it is your database architecture, how data is stored, that is all going, how it will be represented. Now this is the data design at an architectural level. Now how you're going to design at the architecture level. Two levels you have studied, the architecture level and the component level. Now at the architecture level, now you've got multiple millions of businesses across the world. Now, as there are many small businesses, these small businesses are also making use of different databases that is helpful for running different applications. Even the moderately sized business, are you making use of this database that is going to help different applications. Now, the main job is to extract the useful information from the data environment. Now, what is a database? A database is a huge collection of data. Now, what particular data is useful to perform a job that needs to be extracted from this database? For that, you use a data mining technique. You use a data mining technique. That technique is called as knowledge discovery in database, also called as KDD. Now, if you an alternate solution to that is that you can make use of also a data warehouse. Now, this data warehouse is a huge collection of different databases This is going to add an additional layer to your data architecture. This data warehouse, it is a very large independent data and has got access to data that are stored within the database. So from here you can access what type of data is required for the particular business. You can use either of the two techniques. Now the data design at the component level. At the component level, we need to discuss, or we need to follow a few set of principles. The first one is the analysis principles applied to functions and behavior. That is, whatever principles you are applying to each function and behavior within the system, that should also be applied to data. That is, you're not going to completely isolate the functions and behavior and the data that is stored. These need to be connected. That is why you need to apply this analysis principles should be applied to function and behavior and also to the data. It should be applied to both. The next is all data structures and operations to be performed on should be identified. That is, if suppose you're identifying that this particular data structure is going to do some job, the other data structure is going to do other job. Now, what is the job of each and every data structure and operation? It should be known. It should be identified. It should be known. The next is the mechanism for defining content of the data object should be used to define data and operations applied to it. Now, whatever mechanism you're using, whatever technique you're using for defining the content of data object. Now, data object, it can be a role, it can be entity, it can be anything. So whatever you're using for defining that content of that particular data object, it should be used to define data and the operations applied to it. That is, this is the data, and the data is going to do different functions, different jobs can be done. So you're going to use the mechanism for defining your data and also for defining what are the different operations that are applied to it. The next is the low level data design decision. It should be deferred until late in the design process. Now, low level data design is your lowest level of abstraction. That is the highest detail, how data is stored, how it is stored. These levels of detail, it should be deferred until late in the design process. Until you go till the end, you should not focus upon these little details. That is not focusing upon the level of detail. How you're designing it, it should not be shown at the first. If you want to go at the lowest level, then these low level details should be shown, or else you can represent at the high level of data design. When you're making the software at the beginning, you're going to first focus upon the brief things. Then when you go later, when you're continuing with the same design, then you can keep on adding the details. Then representation of data structure should be known only to those modules that make direct use of data contained within the structure. Now, this can also be called as information hiding. Like, what data is used by some specific component, it should be known to that specific component only, so that you can avoid any, so that this is used to avoid any accidental errors. Then a library of useful data structures and operations that may be applied to them should be developed. Now, that is, if you're running a C program for math, you add a library called math.h. The same way, what are the different data structures, data operations that need to be applied? They need to be developed. The next one is a software design and programming language should support the specification and realization of abstract data types. Now, whatever software design you're using or whatever programming language, Java, C, C++, whatever you're using, it should support the specifications. That is, whatever features you want, they need to be present within that programming language, or whatever specifications you want, the specification should be present within the programming language, and the programming language should be able to define this. So it should support all the specifications and realization of abstract data types. Of all the abstract data types, they need to have all the specifications and realization. Now, like an example for realization is, if you've got a printer setup, this printer setup, this is how your realization is represented, a hollow arrow with a dotted line. If you have a printer, then you can have a printer setup. So this is a representation of realization. So these are your, so this is a description of what architecture is. We have completed what architecture is, why it is important, and the two types of data design, the data design at the architecture level and the component level. Then later we'll begin with the architectural styles in the next class. Thank you.